factoring. We did some factoring at the beginning of the year, and now we're going to take a look at how factoring will apply to some algebraic expressions. To begin that process, recall what it means to factor a number. We break it down into components that multiply together to give you that product. 42, you could break it down into 2 times 21, or 3 times 14, or 7 times 6. But no matter which way you do that, you should get the final answer of 2 times 3 times 7. We call that prime factorization, and remember that we could also express prime factorization exponentially. Try 54 and break that down into its prime factors that you express exponentially. That's going to be 2 times 3 to the third. Hopefully you got that, and try number 3. That's going to be 2 squared times 5 squared. Now I want to think about the GCF of the following numbers. For 24 and 18, what would the GCF be? It would be 6. 36 and 90, that's going to have a GCF of 18. Now remember, you can always find the GCF of two numbers by breaking it down into the prime factorization and taking the things that are in common. 36x and 48x. Now we have to start thinking about not only the numerical components, but also the algebraic components. What do they have in common? 36 and 48, my GCF is 12, and both of those terms have an x in common, so 12x is going to be the GCF. So to factor each expression, we're really thinking about distribution in reverse. Can I take something out of each of the terms and then multiply it by some other expression to get the product shown? Taking a look at number 7, I have to look at what the two terms have in common. Well, they have a 5 in common. They do not have anything in common algebraically. So I would remove the 5, and then I would come up with an expression as the other factor that would give me the product of 10x plus 5, which is going to be 2x plus 1. In number 8, I look for a common factor in both. Numerically, I see a 7. Algebraically, I don't see anything. So I'm going to multiply that by x minus 7. In number 9, they don't have any variables in common. They do, however, have a numerical GCF of 6. So 3a plus b plus 9. Now if you think about that, what I'm really doing, if I think of one factor of 42, let's say I know 7 goes into 42. Then to get the other factor that's missing, I'm really dividing 42 by 7, and that gives me this factor of 6. So in an expression like number 9, what I'm really doing there is I am dividing the 18a plus 6b plus 54 by 6. And when I do that, I get 3a plus b plus 9. Factoring and division kind of go hand in hand. Look at number 10 and see what you think. The 72 and the 48 have a GCF of 24. I also have a common algebraic term of p. So if I were to divide this entire expression by 24p, I would get 3 minus 2q. Okay, they both had a p in common, so I took that out, and then the 72 divisible by 24 left me with 3, the 48 divisible by 24 left me with 2, and then I also had that q left over. Look at number 11, 27mn minus 18mnq minus 12q. Well, it's kind of a bummer because these two have an mn in common, and then these two have a q in common. But in terms of all three, they do not have any algebraic commonalities. So I have to go back to square one and just look at the numerical terms. The only thing I can take out here is a 3, and I'm left with 9mn minus 6mnq minus 4q. Take a look at 12 and see what you think. I find that all of the terms have an x component, an x, an x, an x. Oh great, so I can take out that x of all of my terms, and then I look for the GCF. The GCF is just 2, so I'm going to take 2x, and then that leaves me with 7. The x has already been taken out, so I don't have to worry about that, plus 22y, because I took out the x, and minus 3 z. Now we're getting into some more complex algebra where I want to know what these two terms have in common. Well, they do have an x in common. And what would I multiply x by to get x squared? I would multiply x squared by x to get x squared, and I would multiply 1 by x to get x. So this problem, 13, factors into the two factors of x times x plus 1. The beauty of factoring is that you can always distribute to see if you get the same thing back again. So if I multiply x by x, I get x squared. If I multiply x by 1, I get plus x. And so I know that that checks. Try 14, 15, 16, 17, and 18 on your own and come back and check your answers with me. 14 is very similar to 13 with the exception of a subtraction sign, so that one should have gone well. 15, I have a numerical common factor of 3, an algebraic common factor of p, which leaves me with just p minus 2. In number 16, they have a common factor numerically of 6 and an algebraic common factor of x, which leaves me with 2y minus 3x. 17, this one has nice common factors of 7ab. I would have to multiply 7ab by 2a minus 3 to get 14a squared b minus 21ab back again. And the last one, 18, they have a numerical common factor of 5. They both have a p, they both have a q, and when I take that out, I'm left with 4pq minus 7. Don't be spooked by factoring. Have a great night, everybody. See you tomorrow.